Hello, I'm going to talk to you today about our partitioning kits. We have a Partitioning Rectangles and a Partitioning Circles Kit, and both of these form a really good foundation for students understanding partitions, fractions, and area. So, first thing to know about these kits is that it is consisting of, for the rectangles, a large rectangle split into halves, thirds, and quarters in various ways, and the same for two different sizes of circles in the Partitioning Circles Kit. Additionally, within the Partitioning Rectangles Kit, we include 24 of these 1.5 centimeter squares that you can then line up to fill in the complete rectangle that we have here. And they can go in and use a single one of these wax covered strings to see different ways you might be able to partition a rectangle or a circle in half. So you can then challenge the students, okay, how many halves do you have? I have 2 halves. How many fourths do you have? I have 4 fourths. All right, looking at the fourths we have over here and the halves we have over here, is there any amount of the fourths that are equivalent to a single half? And the students should then be able to start building the connection and visually seeing and understanding that yes, 2 of these quarters does equal 1 half. So they're getting a visual and kinesthetic experience involving fractions where they're building them, they're breaking them down, and they're understanding both equivalent fractions and non-equivalent fractions. Beyond that, one of the nice things about this kit is that you can extend it into a lot of different areas. For instance, with these little square tiles, you can start even working on multiplication using arrays. So figuring out the area using multiplication by laying these out and then counting them, but getting the students to not just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, but actually getting them to realize that it is 4 sets of 3, so 4 times 3, or 3 times 4. And so seeing that the same number of squares is going to line up when you do it on this other half that might have a different shape, the students can see that the area remains consistent, but that 3 times 4 equals 6 times 2. One of the activities or challenges you might do with your students is taking these diagonally divided fourths of the rectangle and have them prove that the area of each fourth is equivalent. So one way students might do this would be to take this and actually split one of the triangles in half and then see that you can actually lay the triangles out and they cover completely one of the long skinny triangles. For the Partitioning Circles Kit, it is particularly useful for discussing similar shapes and beyond that, understanding that a third of one circle is not necessarily equivalent to a third of a different circle. Because if you're working with similar shapes here where you have larger and smaller ones, the students have to come to the realization that this 1/3 is not the same area as this 1/3. So you get to challenge them and pressure them to it's 1/3 or 1/2 of what? And they have to start building in that specification. So one of the fun ways to do that is actually have the students give them all each one piece, and you'd want to do them all in the same color then, but have them find their complete set. So you would have the students all go find the other thirds that line up with theirs to create a complete circle, or the other fourths, and they have to each go find the rest of their group. This kit is also really useful for rigid transformations, so students can see that this sector of the circle is actually the same as this one, but it's just rotated 90 degrees, rotated again. And so the students are starting to get interactive experience with transformations. They're starting to understand scale and similar shapes. By comparing the 2 fourths and realizing that the area isn't the same, they can then go in and compare area of complex shapes and try and determine by measurement, by using their rulers, by using the clay, using these additional squares, and that getting the students to realize that not just are these 4 triangles equivalent area, this triangle is of an equivalent area to this rectangle, and this rectangle, and this rectangle, even though they all 4 look very different. So it's starting to build the students her understanding of partitions, of equal shares, and especially of area, and even giving them that foundation for fractional understanding that will be instrumental throughout the rest of their math years.